All right, so on page 25 of your notebook, we're going to be talking about the distributive property today. The notes shouldn't take us too long, and you'll be able to get into your IXL practice. But with distributive property, it's just another way of being able to simplify an expression by using multiplication that gets distributed amongst an addition or subtraction problem inside parentheses. So if we had something like the following, we had M times the quantity, so we're going to have parentheses. We have A plus B. The way that the distributive property works is you're taking the value that's on the outside and you are distributing it to each component or each term that's on the inside. So each of these terms is going to be considered a separate term. So we have the term A, and in this case we have the term a positive B. So all this would look like is that we're going to take the value of M and we're going to multiply it by A. Then we're going to take the value of M and we're going to multiply it by B. And when we simplify it, it comes out to MA plus MB. That is our distributive property. So if you think about it like in a classroom, if I have papers that I need to give to every single student, so I've got a worksheet that I want to hand out to everyone, I'm distributing it to each student in the classroom. That means that me, the teacher, is going to hand every single student inside the classroom that sheet of paper. Now, if I had a student that's outside of my classroom, am I going to go into the hallway and give them a piece of paper?
No.
No, they're not inside of my classroom. So if you think of distribution like a teacher passing something to the class, that distribution only happens to what's inside the parentheses, the classroom, not to anything that would be outside of the parentheses. Okay? Let's try a couple of practice problems. So if we've got 2 times the quantity of 3x plus 7. 2 on the outside, 3x plus 7 is on the inside. We are going to distribute by taking the 2 and we're going to multiply it by 3x and a positive 7. So that's 2 times 3x and that's going to be 2 times 7. Two times 3x, 6x. Very good. All you're going to do is multiply the numbers and you keep the variable. Just like when you're adding x values, you add the numbers, you keep the variable. Here, we're multiplying the numbers and keeping the variable. But that only works because one of them is just a number, the other one is a coefficient and a variable. Okay, so this would become 6x. What about 2 times 7? 14. It's a positive 14, so I have to put plus 14. And there's my simplified answer. 6x plus 14 is the same thing as 2 times 3x plus 7. Let's try another one. we have negative 4 times the quantity of 2x minus 3. So again, we're going to be distributing a negative 4 to each individual term. Our individual terms are 2x and negative 3. 2x and negative 3. 25. Notice I'm including that minus sign with the 3. When I separate them like terms, that minus sign goes with the 3. Okay? So we're going to multiply negative 4 times 2x and then a negative 4 times negative 3. Okay, let's start with negative 4 times 2x. What is negative 4 times 2x going to give us? Say it. Negative 8x. Don't forget your variable. Negative 8x. Right? Negative 4 times 2 is negative 8. The x comes with it. What's negative 4 times negative 3? Use your calculators. Negative 4 times negative 3 is 12. Positive 12. So notice our operation was a negative. Now it's going to become a positive, a plus. Instead of subtraction, it becomes a plus because this comes out to a positive 12. So you have to put plus 12. You cannot keep that minus sign there anymore. Okay? I want you guys to try these next two on your own. I'm going to do number 4 over on the side here. Try these next two problems on your own. It doesn't matter even if we have a fraction, it's still the same concept. You're still distributing using multiplication, okay? Try those two on your own. All right, let's see who got this one correct. Number 3, who wants to share with me what they got for problem 3? All right, Krishna.
Negative 3 times 5x equals negative 15.
Okay.
And negative 3 times 6y equals
Negative 18y. Good. So the final answer should be negative 15x minus 18y. So Krishna said he distributed the negative 3 to both terms. We have a 5x and a positive 6y that we're distributing it to. So that means we're doing negative 3 times 5x, and we're doing negative 3 times 6y. Negative 3 times 5x is negative 15x. Negative 3 times 6y is negative 18y. And there's our final answer. Okay. Let's take a look for problem number 4. Problem number 4. Somebody besides Krishna. Come on, guys. Who wants to try? Emily? What do you think? What'd you get? You haven't done that one? Guys, it's the same concept. It's just distributing. Ioani? 12x and then? And negative 6y. Very good. So, or minus 6y. 12x minus 6y. You're doing the exact same thing. It just happens to have a fraction that you're multiplying by. So you're taking that 3/4, you're going to distribute it and multiply it by the 16x, and you're going to multiply it by the minus or the negative 8y. Okay, so in your calculators, you would just type 3/4 times 16. You would have to put your x in your answer after you've typed it. You don't put the x in the calculator. Don't ever put the x in the calculator. When you do 3/4 times 16, you're going to get 12, and you just put your x in your answer. Then when you do 3/4 and you multiply it by a negative 8, 3/4 times negative 8 is going to give you a negative 2, and you'll just include the y in your answer. So you get 12x minus, oh, I'm sorry, not 2, 6. My bad. 6y. 12x minus 6y. Okay? It's the same concept no matter what. You're just distributing what's on the outside to every component that's on the inside through multiplication. You guys have IXL that practices a combining like terms practice from last week's notes, and a distributive property practice from today. You've got both of those to work on. Go ahead and grab your computers, rows 1 and 2.